Okay, let's talk about vertical asymptotes. Recall first that to find a vertical asymptote, you're going to set the denominator equal to 0, and we're going to solve for x. So if you consider the function f of x equals x over x minus 2, if we focus in on this denominator, if we were to set it equal to 0 and solve, we get x equals 2, of course. If you were to take a look at the graph over here, we can see at x equals 2 we have our VA, and notice how our function is approaching it on each side, getting closer and closer. Alright, let's take a look at another example here. This time we have a function that has a little more to it. So this particular function is given to us in factored form. Now notice here we have a common factor of x plus 4. So we want to be careful when we talk about finding VAs and setting the denominator equal to 0. You want to be on the lookout for common factors. Recall we said earlier that common factors create wholes. So if we were to focus in on where we have a whole, well, we're still going to take that common factor and set it equal to 0 and solve. If we do that, the x-coordinate of our whole is going to be at -4. And if we were interested in finding the y-coordinate of our whole, you'd have to plug into what's remaining. So if I plug in -4 into what's remaining, I have a -3 up top, and then a -7 in the bottom. So I can rewrite this as -4, comma, +3 over 7. So that's the location of my whole. So if I'm interested in finding where my vertical asymptote is, well, my whole occurs when x is -4. Alright, so back up here, I'm just going to write that this is not a vertical asymptote. Okay, a whole is not the same thing. Whatever is left over in the denominator, whatever does not have a common factor in the denominator only, that's what we're going to set equal to 0 and solve. So we can see that at x equals 3, we have a vertical asymptote. So if we were to draw this particular graph, you would see at 3 a VA, and then at this -4 point, we would see a whole. So let's now shift our focus to finding limits. So let's take a look at this example here where we have the limit as x approaches 6, and then we see 3 over x minus 6. Well, just like before, we know our first step is direct substitution. If I put a 6 in for x, notice we don't get 0 over 0, but instead we get 3 over 0, which we know is undefined. Now, what's happening here is when you see this situation, we really have a vertical asymptote at x equals 6. We know that if we were to set that denominator equal to 0 and solve, we would get x equals 6. It's not a whole because there's no common factor. So we definitely have a VA at x equals 6. The question is, what is the limit? Well, your options for the limit, so up here I'm just going to write down that your options are going to be infinity, negative infinity, or does not exist. Okay, that's always going to be the case when you plug in and you get some number over 0. Well, to help us get a feel for what's happening here, without actually looking at the graph, suppose you're not allowed to use a calculator, this is where you want to go very close to the number of interest on each side. So if we're approaching 6, I want to be slightly below it and slightly above it. So sometimes we say to go 0.01 away. So let's jot that down. So to find the limit in this situation, we're going to plug in 0.01 away from the x value. So what that is going to look like is we're going to create two one-sided limits. We're going to approach 6 from the left and from the right. So here's how we would further break this apart. So we want to approach 6 from the left. So that means we want to use something like 5.99. So if I were to plug in 5.99 for x, we would end up with 3 over negative 0.01. And keep in mind that we could always get closer and closer to 6. It could be 5.99999, which would make this 3 over negative 0.00001, alright, which is going to give you a very large but negative number. So in this case, we would have negative infinity. Let's do the last part. With our last part here, 6 from the right, we want to pick something slightly bigger than 6. And again, we generally go 0.01 away. So if we plug in 6.01 for x and pay attention to our sign, we notice that we get a positive infinity. So the two one-sided limits are negative infinity and positive infinity, which means the overall limit, if I go back up here, my overall limit does not exist since the one-sided limits are not the same. Okay, last example. We have an absolute value inside of this function. So x is approaching 1, so if we plug 1 in, notice we get 2 over 0. So again, this tells us that we really have a vertical asymptote at x equals 1. And what we want to do here is plug in values on each side of 1. So let's do that. So as we approach 1 from the left, again, you want to just set up these two little additional limit questions. We're plugging in 0.99 into our function. All right, we have our absolute value symbol there, which is going to turn it into a positive 0.01. So that's going to give us a positive infinity. And likewise, 1 from the right, something slightly bigger than 1. All right, so 1.01. Plug that in, we also get positive infinity. Since those are the same, our overall limit as x approaches 1 from each direction, we say is infinity.